Okay, we've been busy multiplying monomials, and we've worked out some of the rules for the multiplication of exponents. Here's a rule for the division of exponents. It says here that if we have a to the m divided by a to the n, then the answer to that will be a to the m minus n. This m and this m are the same, and this n and this n are the same. Remember that we have to make sure that the bases are the same, and this has a base of a, and this has a base of a. So far, so good. This looks really confusing at first, but if we just apply some simple arithmetic to it, let's see if we can make this make sense. So it's just some simple math here, if you don't mind. Let's do this. Let's just do this. Let's do 5 squared over 5. Remember, 5 is the same as 5 to the first power. That is to say, if you don't see an exponential value on a number, we assume that that value is 1. Let's just do a little bit of color coding here so we can see this. This is 2 here, and this is 5 to the first down here, if you don't mind. And if we just look at this arithmetically, we know that 5 squared is equal to 25, isn't it? So we have 20, whoops, wow. We have 25 over 5, right? Is equal to, well, 25 divided by 5 is just 5, isn't it? And that would be 5 to the first power. Can we agree on that? 5 is 5 to the first power, right? If we don't see an exponent, we assume that the exponent is 1. So let's apply this rule and see if that wouldn't work. Our rule says that we check and make sure the bases are the same, and they are. 5 is the same as 5. And we subtract the exponential value of the denominator from the exponential value of the numerator, and that would give us 5 to the 2 minus 1. Isn't that right? And 5 to the 2 minus 1 is 5 to the first power. It's not that bad. It looks really tricky, but when you just apply some simple arithmetic to it, it works pretty well. So let's try an algebraic example of this now. An algebraic example of this might look something like this. What does the book offer? The book offers us this. The book says it asks us to simplify. B to the 15th divided by b to the 7th. Now we already know arithmetically why this works, right? We already know just using simple math why this works. So ask ourselves, is the base b the same as the base b? And it is. So then what does the formula suggest that we do? It suggests that we take the exponential value of the denominator and subtract it from the numerator, which would give us, wouldn't it? B to the 15 minus 7, right? 15 minus 7. And of course, b to the 15 minus 7 could be rewritten as b to the 8th power. Okay? So there's some reason for it, and the reason that we have some math like this is because, well, what if we had something like this? What if we had 2 to the 310th power over 2 to the 100th power? That would be a lot of arithmetic to do, wouldn't it? Instead, we can just do this. We can say, well, that's 2 to the 310 minus 100th power, otherwise known as 2 to the 210th power, isn't it? Okay, so good work. Good work. The next rule is the Quotient of Powers rule, and I want to show you that quickly. Quotient of Powers. So, Quotient of Powers. Frankly, this is just another example of it. Let's do another example of it really quickly. We have a to the 5th over a, and I'm just color coding this so you can see in your mind the way I'm seeing this in my mind, times b to the 8th over b to the 3rd. So this would be just one problem and in one color, but I'm seeing it in 2 colors because what I'm going to do is, frankly, I'm going to look at it this way. I'm going to look at this as two separate problems, and I'm going to do, right, a to the 5 minus 1, because remember this is the first power, isn't it, times b to the 8 minus 3 power, which would give us a to the 4th power, b to the 5th power as our answer. All right? Okay. Good job. Good. Let's take a look at one more rule. Power of a quotient. Power of a quotient. This is quotient of power. This next one is power of a quotient. So this is power of a quotient. Power of a quotient. And I guess you can memorize the name of these rules if you want, but most importantly to me is that you would know how to apply these rules. And the rule would look like this. It says here that C over D, some number over a different number raised, you know what, let's do it this way. Let's make this more clear if you don't mind. Let's do it this way, okay? Let's do it this way and finish this up. Let's do it this way. Let's say that we have A over B, a number over a different number, yeah? To the mth power. You know what, if you don't mind, I'm going to turn this into mth power, right? Is equal to A over B, but it's A to the m over B to the m. And what we're supposed to get from this is important, really important, is to know that the exponents are distributive over division. And that's all I did there, okay? So the quick example that the book gives us is 2p squared. The book asks us this. It says simplify. This is going to turn to dotted writing, isn't it? Yeah, sorry. 2p squared over 3 whole quantity raised to the 4th power. And I'm asking you to remember that exponents are distributive over division. All right? So our answer here very quickly is this. Our answer is this. Our answer is 2p over 3. Now look what we did here. We distributed this. This is 2 to the 1st, isn't it? 2 to the 1st power here. So 1 times 4 is 4. So 2 to the 4th. 4 times 2 is 8. P to the 8th power. 3 to the 4th power. You can simplify this out, and 2 to the 4th is 16. So we have 16 p to the 8 over 3 to the 4th power is 81. 81. All right? So something to think about. You're doing great. Take good notes. These are the examples right out of your book.